looking on the, we're still taking notes on our day one paper where we're learning about Newton's second law, first and second, but still working with the second law. We're going to look at a man whose weight is 15 pounds, and that's the same as 672 newtons. So you can look at it from the English view or the metric view. Same amount of weight. I want you to find the mass of the man. So you're going from weight to mass, and it's Newton's second law that will help you do that. So taking the sum of the forces equals ma. Remember, weight is a force. When you're standing on a scale, you are exerting a force on it. So these numbers will go in this equation under force. Let's do the mass first in English, so in pounds. We'll do it first in pounds. Find the mass in pounds. So we're going to grab, Emily, number 2, we're going to grab the 15 or the 672.
15.
All right, and then the mass is what we're looking for. It says find the mass. And what's the acceleration on a man who is still? And so we're not looking at an acceleration from pushing a rock horizontally, but a man who is still and who is being weighed, we don't care about his horizontal motion. We are looking at vertical. So can you see what number I'm going toward?
32.
Right, 32. Negative. So we'll also say that the weight is downward as well. All right, so tippy tap that out and give me it to 2 sig figs, Zach, when you get that. The mass.
0.47.
0.47? I got 4.7. Oh, it's 15 pounds. It's not a 15-pound man. Could you go back and change that?
I was thinking that, but I figured
How
you
much more sense? It's not like a really
Alright.
midget.
100 and, well, I guess you could be 15 pounds within a couple weeks of birth, but
Yeah.
you don't usually call him a man at that point.
No, a little weird.
Alright, let's get a, alright, Zach, instead, divide
There you
151
go.
by 32.
4.7.
Alright, and what will be the units? What units will we be? We're looking for mass in English. What?
No. Pound.
No. Right, remember we already had pounds over here on force. So this is a slug. So we have a 4.7 slug man.
Is there such a thing as slugs, or is it just slug?
I am 4.4 slugs.
And what's that now?
Is there such a thing as like slugs, or do you, even if it's like more than one, you say slug?
You say slugs.
Okay.
Yeah. But you can also say a
How many slugs are you
4.7 slug man.
3.6.
But I'll say
No, so you just take your
4.7
weight.
slugs. Alright. Alright, let's go over. We're leaving America and we're going to the rest of the world where we're going to look at the same problem in metrics. So I want to take the sum of the forces equals ma. And we're going to find the weight, using the weight, we're going to find the mass of a man in the metric system. So now we switch over to this number. So Emily Keene, walk us through that. What will go here, here, and here. Again, it's find the mass, but this time in newtons. Find the mass in newtons.
So you take 672.
Right, so this time we grab the 672 because we're looking for newtons.
Equals negative 9.8 times
And times what?
9.8.
Yeah, and we're going to do the downward number and the downward weight. So if you would find the mass.
It would just be 69.
Yes. You got your homework?
Oh, do you want to turn
Wouldn't it just be
Yeah.
69?
Well, I just look at it. Is it correct though? Did you hear the answers? All right. Okay. I'll assume that they're right. You will check them.
Yeah, I checked them with Emily's paper.
All right. Yeah, all right. Where am I writing those? Here. All right, Brian late but finished. Zach late but finished. Okay. All right, now we have back to here. Who was doing that? Emily. What is tippy tap it and what is it?
69 grams.
69 what?
Grams.
Not grams because I erased it.
Kilogram.
Right, when we're working in newtons, we have kilogram meters per second squared. So our mass is going to be in kilograms. All right, I'm going to change this formula when I talk about weight. And because the weight comes up so much, you have to go from weight to mass and mass to weight. I'm going to augment this formula. So here's what it looks like. Here's the weight formula. The weight formula is weight equals mg. And I got that from Newton's second law. And do you see how when I calculate weight, the force is weight, mass is mass, and the acceleration, the only acceleration I'm interested in when I'm weighing something is the pull of the earth, which g is the constant that stands for the acceleration on planet Earth or the moon or wherever you are. So this is the weight formula, and it comes right from Newton's second law. So, and you can see that's what we did here. We did use weight, we used mass, and we used the acceleration due to gravity. So we were able to talk it through without that formula, but now that we've done it, we'll use that formula. Let's go the other way and see if it works, if this formula is sound. Say you can't see this, so this is all gone. You can't see this. Suppose I say to you, I have a 4.7 slug man. That's how you say it. A 4.7 slug man, find the weight. So we're just going to go backwards. This is given the mass. Would you recognize this was the mass? The word slug has to tell you. So find the weight. So simply put, sum of the forces equals ma. And reverse that to the new formula. Weight equals mg. And plug in the values where they go. 4.7 is now the mass. Gravity, since I'm working in slugs, is negative 32. What is the weight? If you multiply 4.7 times the negative 32, you'll get pretty close to 151. We had some rounding, so I think I came up with 150. So, pretty close. I think it was 0.4. If I had another tenth, I could have rounded it up and been exact. So because of rounding differences over here, we weren't exact. But it should be close enough to convince you that the formula works both ways. All right, we'll finish day one by taking someone from the Earth or some object and putting it on the moon and figuring out weight and mass like that. So that will be our next part. You still have room?
From the back.
That's okay. The back is the back. It's good. All good. I'll leave this formula up here only because that is what we're going to need. Let's take an object. Draw planet Earth. Draw planet Earth.
Draw a circle.
And we have an object on planet Earth. I'll put mine on right where we are. Here's the United States. We're going to blast an object from our physics class all the way to the moon. So I'll put the moon out here. The hole's in the moon. Here it goes. It's now sitting on the moon. All right. What we're going to learn today is, given an object in its weight, let's say this is a heavy object, 3,420 pounds. And I want to know how much it weighs on the moon. So find weight on the moon. Find weight on the moon.
Is gravity 1/6 on the moon?
Pardon?
Yeah, what is gravity on?
1/6 on the moon?
Oh yeah, I'll give you the gravitational constant with decimals in a second. So the gravitational constant here, so Emily number 2, which gravitational constant will I use here?
Feet, because it's in pounds.
Right, so which number?
Negative 32 feet.
Right, negative 32. Alright, and then over here, the gravitational constant of the moon is about 1/6 of the Earth. So we're going to use 5.3.
Is that a negative number?
Yeah, when we put it in, we will make it negative. Well, I can call it negative now. Be consistent. Alright, so in order to find the weight of an object, when you take it from one place where g, the gravitational constant, changes, mass is always the same. Mass is how much of something there is. Mass. How much stuff makes up the object? How much stuff makes up the object? So the mass of something, if you're sitting on the Earth, how much stuff makes you, and when you go up to the moon, how much stuff makes you, is the same. Mass is the same everywhere.
Take a chunk of hair off.
Yeah, that's true. Mass is basically the same everywhere. So mass is the same no matter where you are, it's just how much stuff there is in the object. So this object on the moon has the same mass as it does on the Earth. So let's go back to our question. Find the weight on the moon. So in order to do that, we're going to go from the weight on the Earth to the mass, because the mass is the same here as on the moon. So let's grab our weight equation. Weight equals mass times g, and plug in the values. Would you do that now and find the mass of this huge object, this 3,420 pound object? That, I want you to find its mass using the weight formula. So let me know when you got that. Flag me down and I'll peek at it. Step 1, find the mass. Find the mass. All right. You got it? Let's see what yours is. So that's where's the mass? That's weight.
Oh.
I'm
I
looking
didn't put
for
it in the right.
mass.
Hold on.
Okay.
Wait, but wouldn't.
So wait.
Weight equals mg is that. Where's your? Okay. And that's like a 3 sig fig, so switch it to 2.
Okay.
Alright, switch to 2. Switch to 2 sig figs.
Wait, for math. Negative 106.
If you consider
Wait, but.
if you consider g as negative and weight as negative, you'll get a positive.
So 107.
Well, it's,
Alright.
no,
Yeah, it'll
it's
just be
160,
100.
you end up.
107.
Alright.
Miss
Yeah,
Powell, can I
107,
stop it?
except we're gonna deal with 2 sig figs.
Can I stop it?
Yes, ready?
Yeah. Okay.